I'll start. So, hi, I'm Annie, or Wenyan is my legal name, and I am actually a high school student. I was developing a mobile application with Yusuen, and he's from the Polytechnic University. And today I'll just be presenting the mobile application I coded for and how it assists user with diet control. And hopefully it's a very straightforward presentation for you. We'll start. So just as we all know, diet is the method of which people take in nutrients, which are chemical substances required by all lives to produce energy. While the macronutrients provide the necessity for the body to function, micronutrients are also important in building a strong immune system, provide health-related protections against heart disease and diabetes, and support muscle and bones. On the other hand, an unbalanced diet can lead to a variety of diseases and problems, including type 2 diabetes, obesity, hypertension, and cardiovascular disease, or certain types of cancer. First, an unhealthy diet can lead to obesity, which can in turn trigger the development of other diseases. From the graph on the right from CDC, we can see that the percentage of adults aged 18 years and older who have obesity in California has increased from 23.8 in 2011 to 30.3 in 2020. And one of the explanations behind this increased trend is diet. It is not hard to guess that the cause of obesity are sugar, fat, processed food, and fast food, etc. So I intended to develop an app that helps to control the consumption of those nutrients to prevent obesity from increasing the risk of heart disease, respiratory disease, such as asthma, skeletal issues, gallstones, and cancers. If the consumption of saturated fats, trans fats, and cholesterol is too high, there is an increased risk of heart conditions, a common one being atherosclerosis, which is a buildup of fats and cholesterol in the artery walls of the bloodstream, which causes the arteries to narrow and restrict the proper blood flow. And a high consumption of sodium also disrupts the proper homeostasis of the body, as well as the cardiac output. And lastly, the high consumption of sugar and fat can lead to diabetes, which is why diet regulation is a common treatment of the disease. And while there are a lot of platforms and ways to promote a healthy diet, I want to highlight ways that a mobile application may be better and more convenient for users. Well, there are both governmental agencies and private organizations that initiated programs to target nutrition problems and promote health equity. And for example, the CDC has created the ECE, Obesity Prevention and High Obesity County Program, to specifically target the issue of obesity. And other programs of CDC, including the Impact, Reach, and Span, focus on issues of micronutrient intake, chronic disease management, and physical activity level, respectively. However, these programs are mainly found other local organizations, which are located in areas where obesity or certain disease prevalence is high, in order to promote healthy eating. And this can be limiting scale and overlook many people in need who are not living in those areas. And qualifications to engage in the programs can be really complex. So the effectiveness of those programs are also hard to measure because they're expensive and not directly interacting with people that's in need. So it creates many uncertainties to how well the program is running if there is a large data set coming from a variety of locations. And another method for people to promote nutritional health is obviously through a nutritionist. And this can be effective for people who need a very specialist diet with many restrictions and needs, while at the same time being able to monitor their health. And associations such as American Nutritional Association are also training health professionals and practitioners to maximize the benefit of personalized nutrition. And on the other hand, this method has a clear practical, which is that some people are unable to afford the cost of frequent nutritional checkups. And this is in alignment with the economic ladder and the health well-being gradient, at least in the USA, which increases at every social class, and how every American is healthier than those with lower income levels. So therefore, for people in poverty who are afflicted with obesity or chronic diseases that need a nutritionist, such as heart diseases and health diseases, heart diseases or diabetes, they do not have access to such treatment. And in contrast, a mobile application can act as a personalized nutritionist that is free and can offer assistance at any moment. So it is very flexible based on the availability of the user. When they eat a meal, this application allows them to quickly snatch a photo on their phone, which takes 5 seconds, and the app will quickly process the photo and let them know of the nutritional composition. It does not require any commitment from the users, and it will be as effective as the users want them to be. And finally, the target user for my application is people who are either in need of support with dietary issues or restrictions, or anyone that wants to be more aware or that is concerned for their dietary health. So it is pretty general. And the mobile application I made is called Healthy You, and I will go straight into some introduction around it. And we'll start with discussing the AI and the model behind the application. So Healthy You integrates a deep learning model that uses computer vision to achieve its purpose. And I don't know how familiar you're with the deep learning model, but it's just a type of neural network with 3 or more layers and just gathers information and learn from it, similar to a human brain. And AI learns from the data through repeatable loops to increase accuracy. Then it is able to make predictions when given new data. And computer vision just refers to the process that AI extracts data from images in order to train itself using the convolutional neural network, or CNN. When given an image, the AI is able to identify a pattern and convolve the data, then going through max pooling to simplify it. The 2 steps are repeated until reaching a satisfactory result. Then the data will be flattened and the full connection will take place. So through this process, the AI is able to learn when it is given data. And the model so far is aware of thus 30 basic foods just to start with, and identify within uploaded pictures, and provided information for 7 nutrients as well as the caloric level. During the training, the model is given large amounts of images per food, and the images were scraped from Flickr using with the use of their image API. As such, it has consumed many pictures and can consistently identify foods within images. The users can also use the built-in camera from their device to take images of the food, and the application is able to classify and localize the food, then providing the nutritional information of it. And by saving the data of each meal and compiling them together, the application shows the daily nutritional intake of the 7 nutrients and the caloric level on the homepage, which I will go into more detail on the next few slides. And a letter grade will also appear on the dashboard to inform the users on how healthy their diets are. And furthermore, the users are able to upload pictures. The users can also use the built-in camera to search up previous meals, and they can see their past dialogues because it is saved locally. And just for the visual representation for the specific page breakdown of the application, so when user use the application, they will select the category of the meal they're consuming after clicking the camera button on the dashboard, leading them to the category page, which is the second page shown on the presentation. And then they can take pictures or upload them at the camera page. And the AI will be able to detect and recognize food items from the meal using image classification. The nutritional information of each food item is given to the AI, and this information will be pulled up from a dictionary of food information and listed on the result page for the appropriate food. And this dictionary of information was saved earlier, of course, during the development step. And then the application will give the user the option to upload more pictures of their meal until they're satisfied and proceed to the summary page. The AI would add all the information in this meal together to show the users their total nutritional intake. The data of each meal is saved in shared preferences locally to allow the users to search up their past meals at any time. To obtain a grade, the user's average daily intake of each nutrient is divided by the recommended level of intake, and if the result reaches a certain level or a certain threshold, the users will see a higher grade appearing on their dashboard. Their total nutritional intake is also reflected on the dashboard below the grade over here. Okay, and next I'll go over some challenges I met during the developing phase and more details toward the coding and technical aspect of the application. So there are several challenges to tackle when I was building the application, and the first topic to consider was the user interaction with the app. So a healthy is an application that closely tracks users' lifestyle. It is difficult to make it efficient and attractive at the same time, but UI is obviously a big part of all mobile application in design, and it requires comprehensive planning to find the right approach. The application should be convenient to use and easy to navigate, while at the same time providing practical feedback on the user's diet. Since the ideal case for this app is a long-term commitment of upwards at least a month of daily use, it is important that users are able to use the app without getting annoyed or confused in the first couple of days. So that is the first challenge to consider, and a need to weigh out the most important part of the application, then to provide a satisfactory experience even with a simple design. And second, it is important for the AI to be both robust and accurate while also making sure that developing the AI does not take too much time. To increase the effectiveness of the AI, particular food items that are more commonly consumed should be taught to the AI first. If I attempted to make the AI so effective as to recognize hundreds of food items, I also need to spend a lengthy period of time building the application. And because designing the UI and training the system to analyze various food also take up developing time, it is impractical to include that many food items. Thus, a balance must be found to make the AI robust and the developing time efficient. And lastly, about data storage, consideration should be put into how much data is collected from the user, since data must constantly be either written or read by the application. This is an important technical problem to consider in order for the application to run. And two methods I considered are cloud storage and the local storage. And cloud storage is tied to the internet and requires building a sufficient backend so it can hold more data, and local storage alternatively cannot store as much, but can be quicker because it does not rely on internet speeds. I also paid thought to what information from the user is necessary for the application, because privacy can be a sensitive topic and the application does not need to store data that is unnecessary. And eventually I decided on using shared preferences, which is a form of local storage. And on the right side is a code that explains the process in which the user gives the AI an image, either from the camera or gallery, and the AI would analyze it, then give back a result. The analysis of the image happens when the user presses a particular button to proceed in the application, and the AI's prediction will be displayed on result page. The result will be shown on the application for the user, but is not included in the code. And to provide AI with an image, the user has two options. The first is image selection, which is when the user uploads an image from their image gallery. And the second is camera selection, which is when the user chooses to have an image taken from the camera instead. And the AI uses a method called image classification to predict the image, which includes a TensorFlow model that trains the AI. If the AI can successfully predict the food item from the image, it will display the image from the user as well as its prediction in the form of a simple string. To show more information, such as nutritional content, get corresponding food. This one will add the other information on the screen, which is again displayed to the user. And by the way, the app is coded in the language Dart in the app, the Android Studio. Yeah. Okay, and this example code on the right explains the process in which the meal results are saved to the user's phone's drive, and it takes place after user has uploaded all images from their meal and likes to see the meal result. This step is necessary because it allows the users to look up the information later for their own purpose at their time. And this code produces a specifically formatted name and saves the meal contents in a specific way that makes it easier to be stored. A plugin named Share Preferences, which I mentioned several times before, was implemented for data storage. which allows the saving of basic data to the phone's hard drive. Because it is an example of local storage, it maximizes the convenience for users to pull up past meals. About the code specifically, the string generates meal name will generate a name for the meal contents, which will be used for the saving process. Then save name will the save name will create a list of food names that are different from the foods themselves to make the data smaller. And this is important because shared preferences can only save simple data, and the contents of the list can be reverse looked up later to make sure no data is lost during the saving processes. And lastly, this list is saved into shared preferences under the name that was generated by the generate meal name. Okay, and lastly, this code on the right is part of the analytics screen or the home screen, where the user statistics are displayed to them. The purpose of the code is to calculate a grade based on how much the user's diet are reaching certain threshold points. And this is for the users to easier for them to visualize how they're doing throughout the day without showing them all the complex data and calculations that is involved. And the code calculate grade will create a digit as a reference for the letter grade, and first the values for the recommended grade amounts were obtained and set it up. And then the user's average intake of each nutrient is divided over that amount, the recommended value of each piece of food information. And usually this will yield a number between 0 to 1, which get letter grade. Then we'll use this digit to generate a letter grade from F to A. As a result, a letter grade is acquired based on the total grade calculated in calculate grade. And only the letter grade will be shown to the user to improve clarity. And since this is part of the consideration of the UI, and alongside with the encouraging phrase, and the total grade calculated will not be shown to the user. And second, to test out the efficiency of the app, I conducted an experiment to verify its accuracy, and I will be going over it in the next few slides. So the accuracy of the application to correctly identify food items in the images are crucial, and the functionality of the application depends on it. So the experiment was designed revolving around this concern. The result will verify whether or not the AI can work sufficiently, and using this data, areas of improvements can be identified to further progress the development of the intelligence. To carry out the experiment, 30 images of each food were given to the AI for it to identify, which sums up to a total of 450 images. A yes or no answer was recorded to indicate whether the AI successfully identified the food or not, and if not, the falsely identified food item was also recorded. The confidence level is taken note of for the purpose to determine nuance, and the general accuracy was determined by dividing the amount successfully identified for a given food by the amount of images tested per food, and this fraction was then represented as a percentage. And next, the average confidence was determined by calculating the mean confidence for all predictions given per given food. So just for a simple graph, the figure above covers both results for accuracy and confidence levels. Reading from the graph, the least accurate predictions were a tie between cheese, steak, and celery at 0%, and the most accurate answers were a tie between lettuce and popcorn at 100%. The foods closest to 50% accuracy were a tie between cake, fish, and sandwich at 47%, and rice at 53%. Out of the 30 foods tested, 13 of them were over 50% accuracy, which approximately the 43% of all the foods were sufficiently accurate if saying 50% is the threshold. And the average accuracy between all 30 food was 48.93%. For confidence, the lowest average confidence was that of an apple and a sandwich at 55% confidence, and the highest average confidence was that of a banana at 92%. Since all foods were over 50% confidence, we consider them sufficiently confident in all their predictions. And the average confidence between all 30 foods was 71.4%. And the experiment conducted gives us a good indicator as to what the AI is good at detecting and what it cannot sufficiently predict accurately. Foods above the 50% accuracy threshold, with some exceptions, were generally simpler foods such as potatoes and popcorn, as compared to foods such as steak. And these foods are likely easier to predict for the AI because they do not typically vary from item to item in real life. Such explains why fruits and vegetables such as tomatoes, lettuce, and bananas scored high, but foods with multiple ingredients scored lower. Foods such as pizza or steak or ice cream, for example, may have been difficult to predict due to the plentiful myriad of ways that such items are prepared in the real life. And such variance may throw off the AI's pattern recognition and is either a sign that the AI cannot sufficiently pick up on multiple patterns or that our food selection needs to be more precise and rigid. As shown by the graph depicting accuracy and confidence, I don't think there is a correlation between confidence and accuracy. And lastly, by drawing conclusion from results of the experiment, a few improvements can be noted for further development, and I want to discuss three main ones here. And first, the conclusion can be drawn that the AI is capable of correctly recognizing food items, especially with simpler foods, which it can accurately identify with food with higher confidence. However, improvements can be made for the AI to recognize more complex foods, such as sandwiches and pizzas, which had inaccurate readings with moderate confidence levels during the experiment. And to fix this problem, the AI needs to be trained with more legitimate images and would be best to have a better source than Flickr. Once the AI can distinguish the subtle differences between similar foods, such as between celery and lettuce, that was a problem during the experiment, the limitation is sufficiently eliminated. And second, the AI is also limited in food application choice, as its knowledge is limited to 30 so far, while there are millions of food present in the world. To accommodate users' varied diets, addressing their dietary patterns and backgrounds, the AI will be more practical if it can recognize more foods because that will produce more accurate statistics about the diets. However, this limitation persists because new choices of food must be added and trained manually, which take a lot of developing time. And third, the training data for the AI is currently scraped from Flickr, which mentioned is not a viable long-term choice because not all obtained images are relevant or appropriate for training purposes. And as a result, the training would go poorly, as the experiment shows, and the AI would need to receive more valid training in order for its predictions to be sufficiently accurate. And that is thus far the summary of the mobile application I developed, which the information are also stated in the paper. And thank you for listening in to me and just staying through the conference. And I guess if you have any questions, you can also feel free to ask me.